So here is a question. Have you already found h of t?
I believe so.
Okay, yes. Okay, so the question is, I have three signals, f of t, g of t, and h of t. F of t and g of t are given. H of t is computed by this formula. The question is, what is the total energy of FGH? And what is the overall power of FNH? Is the question clear to everybody? So that's what we are trying to solve. Because I don't have the H here, so I will only solve it for F and G. How do we find the total energy of F and G? That's first thing first. The total energy of F will be negative infinity to infinity absolute value of F of t squared dt. So that's going to be the total energy of F of t. Is everybody following? Right? The absolute value square integration. But now you can see f of t is non-zero only between negative 3 to 0. So therefore, between negative 3 to 0, I can change it to 1 square dt. So the final answer is 3. The total energy of f of t is 3. Is everybody following the question? Okay. We can also repeat the same thing for g of t. G of t. So g of t from the beginning. So g of t again is going to be negative infinity to infinity. Absolute value of g of t squared dt. Is everybody following this so far? Okay. How do I continue?
You rebound it with t, so the bounds have to be from as long as t is less than 2, so from negative infinity to 2.
Very good. Negative infinity to 2. The integrand is exponential pi t, absolute value square is exponential 2 pi t. So exponential 2 pi t. Okay. Do you need my help to continue, or I think you're good?
No, okay.
Thank you. So the answer will be both are finite, finite and finite, finite and finite. Okay. The H, which we didn't have time, I believe we are probably going to go over it on Monday's lecture. Okay, so but H is a little bit harder to compute, but once you compute it, you can also use the same formula to find the total energy.
Thank you.
For overall average power, we can only work on F. So the way to solve it is going to be T 2t over 1 negative t to t f of t absolute value squared t. And then take the limit t goes to infinity. So that's how you find the overall power, which is from negative t to t, 1 over 2t limit. And in this particular case, because the total energy is finite, overall power is always to be 0. Because it's going to be a finite number divided by infinity. The example we covered in the lecture, finite number divided by infinity, the final answer is going to be 0. So the overall power is 0, and we say it's a finite power signal. Is everybody okay with the solution?
So because it has finite total energy, the power overall has to be 0?
Has to be 0.
Okay, and that still counts as finite because 0 is a finite.
0 is considered as finite. Very good.
Okay.
The total overall power will be 0, still counted as a finite power signal. Is everybody following? Have I answered your question?
Yeah, thank you.
Okay.